So here we're going to run an example of how to string geoprocessing tools together. I've typed up a couple of sample questions. Number one, we want to find the area of the chemical spill that coincides with the grassland habitat, which would be this area here. That we find the area and then calculate the area. And number two, find the sample points with parts per million higher than 0.06 parts per million within 25 kilometers of our left, I'm calling this the left river, that also are in the grassland habitat. I want to make a point real quick. There are a couple of different ways to do this. The way I am doing it is just the method that I think would work. Just stick with me. We'll definitely get the answers out of this. So, number one, find the area of the chemical spill that coincides with the grassland habitat. This is fairly straightforward. We need to find the area that overlaps between chemical spill and grassland. So in order to do that, we can just go ahead and run a quick intersect. Let's grab grassland and chemical spill. And always making sure it's going to the right folder. Let's say pollution intersect. And go ahead and run that. There we have our intersected grassland and chemical spill area. We should intersect. We can open the attribute table. And because it was an intersect, we have the attributes from both. Let's go ahead and do an area calculation where we can add field. We want to make this double precision, and we will call it area in km. I recommend when you are creating area or length files to always provide the units in the name. It's not always clear if you do not do that what units you are using to calculate the attribute field. So within area km, we've got a calculate geometry function. It'll automatically guess that you probably want area. This is a polygon. One thing to be careful of, again, is units. It'll default to square meters. We want to go ahead and let's say square K. And very quickly, we have 331,398 point whatever areas that are coincident between the chemical spill area and our grassland habitat. Go ahead and turn that off. Question 1, we have answered find area of chemical spill. Good. So, number 2, find sample points with parts per million higher than 0.06 parts per million within 25 kilometers of our left river that also are in the grassland habitat. There are a couple of different ways to tackle this. First of all, we need to break the question down. Where are we looking? So, within 25 kilometers of our left river, if you're asking me, that's the first thing I would pick up on. So we want to pull information involving this river. So we go to our river file and let's find out which one of these is the left river. Okay, so FID1 is the left river. One thing I want to point out, when you are running geoprocessing tools, if you have a file selected, it will go ahead and run it just on that selected file. So what I mean by that is when we run the buffer, because this is selected even though I selected it by hand, the buffer will only run on the file that I have selected. So we have buffer and we have our left river selected. Now the buffer is a tool that we are going to use to create our 25 kilometers away from the river. So input features, we've got rivers, and we're going to call this left riv buff. And units, we're going to go with kilometers and 25 kilometers. And again, it'll run just on this selected file. So if you run a spatial query or a non-spatial query in order to pull out certain information with the query and then run a geoprocessing tool on that, it will only run on the selected features that you've used to find with the query. So there we have our buffer. This is area within 25 kilometers of our left river. So let's go ahead and clear selection as usual. Now we're not so much interested in the river anymore as we are interested in the points that are within 25 kilometers of that area. So what we're going to do now, my preference is to run an intersect, keeping in mind, as always, that the intersect will produce the lower geometry. We're going to intersect our left river buffer with our all points file. And by lower geometry, what I mean is it will shoot out because we are intersecting a two-dimensional object with a zero-dimensional object. It will shoot out the zero-dimensional object. Or between the river buffer and the points, what this intersect will produce are the points that are coincident between the buffer and the points. Let's call this buffer point intersect. Okay. And okay. So those are our, let's make them yellow, a little bit larger. Those are the points that are coincident along the 25-kilometer river buffer. So, what's the next step? Find sample points that are higher than 0.06 parts per million. We've got these points that are coincident with the 25K buffer. What we can do now is run a non-spatial query in the attribute table. Select by attributes, and we can do chem ppm, let's say greater than 0.06. Those are queried. Again, we haven't created a file. It's just saying, hey, these are the points that are within 25 kilometers of the river that have a chemical concentration higher than 0.06. So our query is complete, except now we need to create the standalone file. And we'll call this ppm 0.06 and save that. We want to go ahead and add that to the map. Let's turn this off and let's create our points. Let's make them a little bit larger. And then we have our points that have fairly high concentrations that are within 25K of our left river. And our final question is also within the grassland habitat. And like I've been saying, there's a number of different ways we could do this. But let's go ahead and try select by location this time. And we want to select from parts per million 0.06 that within our data grassland. And what is the operation? Show me the points, parts per million 0.06, these reds, that are coincident with our grassland habitat. Go ahead and hit apply. Those are our points. Again, it is a query. Final operation, we'll go ahead and data export. And let's call this ppm 06. Oops, ppm 06 grassland. And go ahead and set that up. And now we don't need ppm 0.06. So based on the questions given, we now have two answers. Let me make that bigger. We got our points that have a high concentration within 25 kilometers of our left river that are also in the grassland habitat. And we also have the area of the grassland that is coincident with our chemical spill area in units kilometers. So in this video, we've strung together, let's see, select by attributes with the parts per million, select by location, the areas that intersect between grassland. We went ahead and took a look at if you select an area by hand or with a query, the geoprocessing tools will only run on the selection. And let's see what else. I think that's about it. Okay, let's say go ahead and as always, we'll go ahead and clear, and we have our two answers. That's it for stringing tools together.